Hello and welcome to your quick guide to car park ventilation. Firstly, let me introduce myself. My name is Andy Davis and I am the Turnkey Fire Safety Sales Manager at ktGroup. Here are my contact details for any questions or queries you may have following this short webinar. I'm 34 years old. I like playing sport in my spare time. I'm an avid Aston Villa supporter, and to me, nothing beats a chippy tea. We offer a complete turnkey solution on car park projects, from design to supply to install and wiring, and then through to commissioning and maintenance. This has many benefits for the property owner, the consultant, as well as the contractor. For the property owner, our proven system delivers a reliable solution with total communication between the products and other systems. Low energy consumption also lowers the running costs. For the consultant, the use of HT certified and CE marked products, as well as in-house CFD for ease of acceptance by authorities. And for the contractor, total responsibility from design to completion, installation and wiring by expert contractors, and knowledgeable project management for on-time delivery. Approved Document B relates to the fire safety. For natural ventilation, with permanent openings open-sided and above ground car parks, there must be a free vent area of 5% of the floor area, of which half must be split between two opposing walls. For natural ventilation where it's not open-sided, there must be a free vent area of 2.5% equally split between two opposing sides, and the openings can be at ceiling level. For mechanical ventilation, there must be 10 air changes an hour. The extract duty must be split between two fans, and the extract fans high temperature rated for 300 degrees for 1 hour. As you can see, the complexity of the design increases depending on the system required. The most common system we work on is a smoke clearance system, where you have to manage the smoke based on the volume of the space and the air changes per hour in emergency modes, while also providing day-to-day pollution control ventilation. There are different types of systems that can be used for car parks. One of them is a ducted system, as shown in the diagram. The supply air would typically come in via exit and entrance ramps. Extraction would be 50% at high level and 50% at low level. There is a downside of this system, as in emergency mode, smoke tends to travel high, and that would only give you a 50% extract rate. The system that we would recommend is a jet fan system. Depending on the size and layout of the car park would depend on how many jet fans are required. The fans would be laid out in a way that there are no stagnant areas in the car park. As you can see from the drawing, the supply air would enter the car park and would be thrusted towards the track. When clearing smoke, it is far more effective system, as the fans are mounted at high level, not a mix of low and high level like the ducted system. This system would also be much easier to install and design. When designing a system, it is important to use CFD to validate it. The CFD analysis will help us determine where the fans need to be positioned and how many fans are required. It will also show us how the system performs in certain scenarios. Drawing A shows a car park with varying levels of contamination. Drawing B shows ventilation situation. As you can see, a massive difference. CFD analysis will also show us how a system performs during the event of a fire, and it will give us an assessment of smoke density, optical visibility, and also temperature distribution. Again, this helps us determine where and how the fans are positioned. This video analysis shows us high levels of carbon monoxide in a car park. As you can see, once the ventilation system is in operation, the levels of carbon monoxide drop. Obviously, this video is a sped up time frame, but it clearly shows the importance of a well-designed ventilation system. Finally, many thanks for your time today. Please contact me if you have any questions, and also a very Merry Christmas. Thank you.
I'm your store manager for today. My name's Simon Plummer. I'm the National Fire Safety Manager. You can see my contact details there. So if you've got any smoke shaft inquiries, please contact me. The scope of the presentation of what we're going to be talking about is about smoke control and its intelligent ventilating within a building. For smoke shafts with this system, we're looking at a single shaft system, 20 stories or less, for means of escape and firefighting. Here we have a statement by Gary Johnson, Head of Business, Fire Safety, South Wales Fire and Rescue Service, which is basically saying that for a system, what he's looking for is a robust system there, which will actually work when it is needed to. In that with a fire brigade arrive, one thing they're not going to be looking at is to be fiddling with controls. They expect it to be a fully automated system. Why do we have smoke shafts? What is their purpose? The main purpose is to protect the common escape routes from the multi-level buildings, basically means of escape. Secondly, it's to provide safe access for the firefighters in tall or large buildings where the stairs are utilised for ingress to the seat of the fire. There are two main types of smoke shafts. First and foremost is the natural smoke shaft, and with that system you have a travelling distance of 7.5 metres. The other system, which has become more prevalent in the past 20 years, is a mechanically smoke shaft system. These systems are fire engineered and have extended travelling distances, twice that of a natural system at 15 metres long. Here is a natural system, which is the only system which is an approved document B. Basically, for the air path, the air comes down an air opening vent, top of the staircase, down the stairwell, through the open door, into the lobby, out through the lobby vent damper, into the smoke shaft or chimney, depending on how you wish to name it, and then out through the top of the building. The main thing about the natural system is that it has a shaft cross-sectional area of 1.5 metres square, with an area at the top of the shaft of 1 metre square and a lobby vent area into the shaft of 1 metre square. So it is quite large when you compare it to a mechanical shaft. As you can see, a very similar air path. Air comes down the opening vent, through the door, through the lobby damper, up through the shaft, and there it's extracted. And here's the difference with a run and standby fan. The advantage of this system is that the shaft is much smaller at 0.6 metres squared, giving you a much more lettable space. It is you can use a lot longer distances at 15 metres there. And the main thing with the mechanical one is that you are guaranteed a smoke extract rate. You're not at the mercy of nature, which you are with the natural system there. Moving on, where does the smoke shaft sit within the fire safety legislation of the UK? Well, at the moment, today, it's in the middle of the slide. It's an accepted good practice. There is no set single standard for it. If you go for a car park, you have a car park standard of BS 7346 Part 7 there. So at the moment, that is where we are. We're hoping to bring the Smoke Control Association guidance into a BS standard, which will be its next step. So at the moment, the actual mechanical smoke shafts are made up of relevant standards to it as practical. So its parts are taken from approved document B. the various parts of EN 12101 from parts 1 to 13, and obviously the Smoke Control Association guide. For our system, we've also gone further and got ourselves local authority building control approved. Here you can see the certificate number in the bottom left-hand corner. With all these systems, we've done some CFD analysis here to actually show that the system does work. Here you can see 4 different situations. I'll show the animations. Here we go. Basically, what this smoke shafts are showing here is you've got a long corridor at 6 meters cubed per second and at 5 meters cubed per second extract rate, and a short corridor at 6 and 5 meters cubed per second. And as you can see, the main thing to see in the video is that the staircases are free of smoke. That's the main thing you're trying to do, is to keep the staircase free from smoke and also the corridors free from smoke. This is when the fire brigade arrive and they open up the smoke-logged apartment door. There. Just rerun it again for you. So, first of all, the smoke logs in the apartments there. The person in the apartment escapes and you see a plume of smoke come out. It's then that smoke is then extracted into the little red dot there. Here we're now waiting for the fire brigade to arrive. When the fire brigade arrive, they will obviously come through the staircase door and into the apartment door, and all the smoke will come out there. And as you see, so doing a whole study of all these CFD data banks, we found out that there was a common extract rate of around 6 meters cubed per second. That caters for most of the common high-rise buildings in the UK, with all the different fire loads and the different geometric geometries of them. From that, we basically came up with a modular approach with modular parameters. Basically, with our system, we're looking at a maximum of 20 stories, 15 meter travel distance from the apartment door to the staircase door, extract point at least 2/3 distance from the inlet source, and with only a single inlet and extract point. The main point of the actual smoke shaft is the shaft itself, and where these have to be constructed to EN 12101 part 6, and they have a very low leakage rate in them, because obviously you want to be extracting the smoke from the lobby vent door and not from everywhere else within your smoke shaft itself. With the actual modular system itself, we have our modular parts there. We have the air-operated vent, top of the staircase, the lobby vent doors, the door actuators, the panels that actually make it work and control it. And obviously, last but not least, we have the fans at the top of the actual smoke shaft system. If you need any more information, you've got my contact details at the start of the presentation. Wishing you once again a Merry Christmas, Happy New Year. Look forward to receiving your inquiries. Thank you.